algebra here for this. Now again, we like these again because we can get exact answers, okay? Unlike yesterday, if we were to do that question, I'll do that at the end of the period. I'll do that question that we did with the 10 cent and the 22 cent and solve it with algebra, and you'll say, wow, I can see the exact value is x equals 646 and y equals 293.8, right? You get an exact value instantly, okay? And it'll be efficient and quick and wonderful, and you'll be happy. If you're not happy, but it'll be wonderful, okay? Are we almost done with those 2 pages? All right, here we go, example 1. Solve the linear system. Now, in the good old days are even as far as my warm-up today. We would have had to graph this one. Okay? We're going to do this a little bit differently. Can someone be brave and tell me how I know these lines are going to actually intersect? How can I tell that there will be an intersection? Go ahead. I hope you're saying they're all different slopes. That's what I hope you're getting towards there, okay? So as soon as here, if you take a look, because we have 3x and 5x, those have to be different, okay? So remember, when 2 lines intersect, go back, it says isolate one variable, they're already isolated. So what I'm going to do is I'm going to say, since y equals y, since they have to be the same, what I can say is that the right-hand side of the top equation is equal to the right-hand side of the second equation. So what I'm going to do, I'm going to take this 3x minus 2 and just move it right over here. Good. So I'm going to say 3x minus 2 is equal to 5x plus 2. So you see what I did there? The y's have to match up. Hold on a sec before I blow your minds here. Since the y's have to be the same because they're the same value like when they intersect, that means the other side of the equation has to be the same. Okay.
As long as the y values are the same.
Well, because remember, when we're solving an equation, we want the y to be the same and the x to be the same, right? So we can just do this. It's a beautiful algebraic tool. Okay, now it's just plain old algebra. Desiree, I'm going to pick on you. Can you solve for x, please? Give me one first step, please. No, don't freeze. Okay, it's okay. I'm sorry to put pressure on you. Sure, yeah. Yeah, Jenna, go ahead. Yeah, good. Go ahead.
Bring the 5 over, so it's 3x minus x.
Okay. Yeah.
Positive 2 plus 2.
Okay, so what? Very excellent. What you did was 5x on the right is negative 5x on the left, right? And then negative 2 on the left is positive 2 on the right. All right, Natalie, what's 3x minus 5x? Good. And 2 plus 2 is? Wonderful, excellent, awesome. All right, Emily, what's the last step, please, to solve for x? Good. Okay. Okay, now lickety split without graphing. We've just found out what x is. Think how long it takes us to graph. It took us a huge amount of time. Okay, we still need to get the y coordinate. So in order to get the y coordinate, what we're going to do is pick either equation here and sub it back in. It'll work for both of them, actually. Okay, so we're going to say to get y, sub x equals 2, negative 2, sorry, into either equation. Lexi, what's your favorite equation, number 1 or number 2? Number 2 works good for me because there's no equations here. I'm going to put in brackets either one will work. But generally you want to pick the simplest one that you can. Okay. Now when you're substituting in, this is like, whoops, this is our fault. This is like a table of values here, okay? So what you're going to do is everywhere you see an x in the equation, you're going to plug in a negative 2. So it's going to go y equals 5, bracket, negative 2, plus 2. So we just replace the x with negative 2, just like a table of values. All right, Aiden, you should be happy you're going Aiden today. This is like a dream come true, I'm sure. Aiden, what is 5 times negative 2, please? Negative 10 plus 2 is. Great. Now, what we need to do is, we have to do a therefore statement, because I mean about this. We're going to say for our therefore statement, therefore, our POI, what that stands for is point of intersection. Is -2 and -8. Well, wasn't that nice compared to graphing? It is beautiful compared to graphing, I think. I know there's one person sitting at the back that says to themselves, I love graphing. Well, graphing is wonderful. Kelly, I know you love graphing. But this works beautifully too. Yeah?
So why is that?
I'll see it visually, that's what. Okay, because it should work in all different things, right? If I were just to give this to you guys here, the other problem with this is that it's very easy to make a mistake. Let's say you screw up your algebra, and you can be way off and have no idea if you're even in the right ballpark, right? So the nice thing is about graphing, you can sort of visually see it, right?
Mrs. Ladd, could you please dial 3012? Mrs. Ladd, 3012, please.
I'm going to get you guys to try this one for me, and then we'll take it up in class in a minute or two. So try example 2 yourselves, then move on to another one. Example 2 says, find the POI of y equals -3x plus 1, y equals 2x plus 11. Oh boy. Okay, so take a minute and solve this one. Follow along the same steps did for the first example, and you'll be fine.